Let's take a look at section 8.5, using the recursive rule with sequences. Now, in this section, we're going to talk about two rules. The first one right here is this explicit rule. And this explicit rule right here gives a sub n as a function of the term's position, the number that it is, number n, in the sequence. Okay, and hopefully as we take a look at the two different rules and going over the questions, I think it'll be able to better explain this rule right here. The second rule is the recursive rule. And the recursive rule, it tells you right here, first off, it gives the beginning terms of a sequence. So a sub 1, a sub 2, or some number. And then the recursive rule tells how a sub n is related to one or more of the preceding terms. So we're kind of working backwards right here. Recursive, reverse. Think about that, right? If they tell you what the first term is, well, what they're saying to get the next term, you're going to take that next term. In order to get the next term, you will take the previous term and like add whatever the common difference is. Okay? If it's arithmetic, you're going to be adding, or if it's geometric, then you will be multiplying. So let's take a look at the two recursive rules. The first one right here for arithmetic sequence, and it's a sub n is equal to a sub n minus 1 plus d. Most of these should make sense. Hopefully now you realize when we talk about n minus 1 in an equation, that right there will represent the previous term. Okay, so like I said, what's going to happen right here is you're going to take, if you want to find the fifth term, well, this is saying you take the fourth term and then add the common difference to it. Or if it's geometric right here, if we have right here, think about it, if we have a sub 5, what you're going to do is you're going to take r times a minus 5, a sub 5 minus 1, which is the fourth term, and then multiply the common ratio to get the next term in your geometric sequence. Well, let's try to put this into practice right here with our extra practice. We have exercises 1 and 2 says write the first 6 terms of the sequence. I take a look at number 1. I'm looking at the bottom equation. That right there looks like it's arithmetic. And they want us to find the first 6 terms of the sequence. So let's do this right here. We know the first term, a sub 1 is equal to 2. So I'm just going to go ahead and list that down right here. So now in order to find the next term, a sub 2, according to this equation, it says we're going to take a sub n minus 1. So this a sub n minus 1 happens to be the first term, right? If I take 2 minus 1, that gets me the first term, which happens to be equal to 2. Plus 5. And so the second term is equal to 7. And it makes sense, right? You got to start with the first one is 2, add 5 to it, it's supposed to be 7. But practicing and understanding this recursive rule right here. So next up, we take a sub 3. And what that means is we're going to take the second term, which we now know is 7. And then we're going to add right here 5 to this. And what does this now equal? We've got ourselves 12. All right, so let's continue this process, a sub 4. And that right there will be now the previous term right here, which was 12. And we're going to do plus 5. And that is now equal to 17. All right. Quickly going through this right here, we'll take 17 plus 5, and that now equals 22. And then for a sub 6, the sixth term, we've got 22 plus 5, and that equals 27. And there you go. We have our first 6 terms. Next up, let's take a look at number 2. They get a little more complicated right here because in the rule, they've got 2 times the function of the previous term, right? N minus 1. So let's go ahead and get started right here. I'll start with f sub f0. That's going to be 1. If we go ahead and take 1 right here, what's going on is this. We are going to take 2, right? And we are going to take the function of n minus 1, the previous term, which happens to be 1. And from there, we'll go ahead and get our answer. And our number is going to be 2. All right? So let's repeat this. We've got f2. We start off with 2 times, and then what are we going to multiply it by? The previous function, or the previous sequence, which we happen to get was 2. So 2 times 2 is 4. Right, next up, we got f sub, or f3. We're still multiplying by 2 because that's represented by the first part in the equation. I'll highlight that for you right now in case you didn't get that. And then this next number is supposed to be the previous term, which is 4. And there you go, that equals 8. Next up, we got f4. Right here, we've got 2 times the previous term, which is 8, and that's equal to 16. Next up, we got f5. 2 times the previous term, 16. This equals 32. And then finally, actually, we're good because that's 6 terms right there. Okay, so there we go. Super. All right. Let's go ahead next up and go to number 3. It says write a recursive rule for the sequence. So remember, in the recursive rule right here, we need to know what is the common difference or the common ratio. Okay, we got to determine which one of those do we have. And so let's take a look first off and determine that. I will look from 3 to 9. Or sorry, 9 to 12, that's plus 3. 12 to 15, plus 3. 15 to 18, another plus 3. 18 to 21, plus 3. So this right here, I know that we have is arithmetic. Okay, we got a arithmetic sequence. So what do I do now? All right. It looks like they tell us what a sub 1 is. Right? They show us that it is 9. So all we need to do now is take a sub n, and we're going to go ahead. Remember, the equation is a sub n minus 1 plus d. Right, so all I need to do is go ahead and my answer is going to be a sub n is equal to a sub n minus 1 plus the common difference, which is 3. And there you go. Okay. So they want 2 things right here in your answer. We need to know first off, what's a sub 1. So I went ahead and did that. And there you have your recursive rule. Now we finish number 3. Let's see number 4. I take a look. Is it arithmetic? 20 minus 30 is 20. 20 minus 30 is an 8. So it's not arithmetic. Let's see if it's geometric. And remember, the rule for that, we take the second term, divide it by the first term, and we got 2/5. So if I take 20 and multiply that by 2/5, does that get me 8? And if I take 8 and I multiply that by 2/5, does that get me 16 over 5? And take 16 over 5 and multiply by 2/5, does that equal 32 over 25? And that does happen to be the case. So we have ourselves geometric right here. So let's put it all together. Remember, we first off need to know what is the first term. And the first term, a sub 1 is equal to 50. So let's make sure we state that. And then our rule right here is going to be a sub n, and that's equal to, remember, it starts off with the ratio. and we determine the ratio being 2/5. So we got 2/5, and then that's multiplied by a sub n minus 1. And there is your recursive rule. When you take a look at problems 5 and 6, things get a little bit complicated there. We're not going to worry about that. And let's move on to number 7. Write a recursive rule for the sequence. So, well, in order for us to write the recursive rule, first off, we got to figure out what is the first term. And then we have to determine, well, what happens to be our common difference or common ratio. So if I look right here, let's start off. Remember, we have a sub n, or let's figure out a sub 1, and it's 5 minus 3 times 1. And so a1 right here ends up being 5 minus 3, which is 2. Okay, so this right here, we need to know, or we've got. Next up after that, what is happening to to the problem each and every time? If this happens to be arithmetic, are we subtracting 5 or adding 5 each time? Or are we subtracting 3 or adding 3 each time? And hopefully you realize at this point in time that -3 is what's our common difference each and every time. Okay? That right there, boys and girls, is your common difference. So we have a sub n, and that's going to be equal to, we got our equations a sub n minus 1. Remember, because we're dealing with the recursive, and then we have minus 3. And then I'll go ahead and put right here, a sub 1 is 2. And there you go, there is your recursive rule. Let's go next up to number 8. All right, so remember, things for our rule is we got to figure out what's the common ratio, what is the first term. Okay, so let's determine a sub 1 first, and we'll go ahead right here. We got 1 minus 1, that's 0, so -2 to the 0 power ends up becoming 1. All right, and then we're going to go ahead and multiply that by 10, and so a sub 1 is equal to 10. Hopefully we remember from this equation right here, it's a sub 1. Remember, if we take a look at this top equation, it's a sub 1 times r raised to the n minus 1 power. So that tells me that this right here is r is -2. So to write our recursive rule, I've got a sub n is equal to r. We'll go ahead and put -2 right here. And then it's going to be a sub n minus 1. And so both of that combined, your recursive rule. Taking a look next at number 9. Looking at the problem, looks to me like it's arithmetic or arithmetic. So remember, once again, that 8 right here will represent your common difference, and then we have to start off and find a sub 1, and a1 is going to be equal to -1 plus 8 times 1. Okay, so that ends up equaling right here -7. So for our rule, we have a sub n is equal to, we have a sub n minus 1, and then we've got ourselves our common difference, which is going to be plus 8. There's your rule. All right, so hopefully we got that point, we have that kind of set, and we are good to go right now. The last thing then, I'll skip number 10. We're going to write the explicit rule for each sequence. Okay, right here we have the recursive rule. So remember, things that they give us, we have a sub 1. Great. And then if I take a look right here, looking at this equation, doesn't that look like it's arithmetic? And that plus 7 is in the spot of your common difference? I certainly hope so. So what that'll allow us to do is write our explicit rule, which is what we've actually been writing so far. A sub n, and remember for arithmetic, it ends up becoming A1 plus n minus 1 right here times your common difference. We'll plug in A1. They gave it to us -1 plus n minus 1 times 7. Okay, so all I need to do now is take that, plug it in. We plugged it in, and then let's go ahead and distribute 7n minus 7. And let's go ahead and rewrite this where we know how to in the proper format. Variable first, and then -1 plus -7 minus 8. All right, and there you go. There is our explicit rule. Something that we've been very familiar with time and time again. Okay. Next up, number 12. So right here, looking at this equation, this right here, our recursive rule, that looks very familiar, and this looks like it is geometric. And if we remember in geometric, the coefficient right there is r. So r happens to be 0.2. We have a sub 1, and let's remember our equation. It goes a sub n is equal to a1, and then we have ourselves times r raised to the n minus 1 power. Right, that is the explicit rule. So a sub n is equal to 24, and then we got ourselves times 0.02 raised to the n minus 1 power. And just like that, we've got our explicit rule. Okay? I hope at this point we're pretty much good to go. Now you know how to find the explicit rule when given the recursive rule, and you can find the recursive rule when based off of the information given. All right, so there you go, section 8.5. A little shorter than some of the others, huh? Especially in this chapter. Appreciate it. If you learned something right here, make sure please like the video, please subscribe, even leave a comment, and I'll get back to you. Thank you very much.